just in case you're curious, I thought I would post solutions to the final exam, at least to some problems on it. Not all of them. The first two problems are pretty routine, derivatives and antiderivatives. I don't think there's any particular challenge to those. If you knew the right information, they should be pretty easy to work out. I want to talk about number 3, though. We have the function x log x, and parts A and B are, I think, are super routine. On to find the slope of the tangent, we need the derivative. So using the product rule, I'm not going to write all the steps out. I'm just going to write the result. You get 1 plus ln x. And so the slope, again, that's the product rule because our function is a product. So to get the slope, we plug in the value, which is the square root of e, which is 1 plus the natural log of, we can write the square root of e as e to the 1/2, which is 1 plus 1/2 makes 3/2. I think that all 3 exams had the same value here. On part B, you all had different values. Here we want the slope to be, this exam, I think this was the 8 o'clock Friday test. We want the slope to be 2, so we're just going to set the derivative to 2, which means ln x has to be 1, which means x is e. The interesting part here is part C, I think. Notice it's bolded and in italics. I'm going to slide it up so I have space to work below here. By carefully examining the work in A, find an antiderivative of the ln x. Well, in part A, we showed that x log x, hopefully you did. If you didn't, then you're in trouble here on part C, that the derivative of x log x is 1 plus log x. Now, every time you get a derivative fact, we can turn it into an antiderivative fact. So the fact we get here is the antiderivative of 1 plus ln x is x log x. Okay, and on the right-hand side, we have a plus sign. Sorry, the left-hand side. And we know the integral of a sum is the sum of the integrals. So we get the integral of just 1 plus the unknown. And that equals x log x. And this guy right here is equal to just x. And therefore, subtract them over. The antiderivative of ln x dx is this piece, x log x, minus x. Okay, I said find an antiderivative, so we'll call it good right there. All right, I should have said before I started the exam, I have not graded a single problem on a single exam, so don't read into my comments things that might make you think about your exam. I'll grade them, I don't know, before the end of next week. All right, next problem.